seem to recognize that I am. Let me know if you can see my stream. Okay. Trying to stream Indie Dev right now, but Twitch doesn't seem to recognize that. Let me know if you can see my stream. Paste. Well, wasn't that a fun thing to post? Let's try actually, Oh, we're streaming now. Hurrah! Okay, so for some reason, Twitch was just being really grumpy about it, but after rebooting several times, it finally woke up. Okay, so Mr. Idle says it works, and Pink Hair is evidently watching, although he's probably got his sound off and doesn't realize that I am broadcasting, because that is the normal method. Alright, so sorry about all of that confusion. I am seeing flickers on my end. Please tell me if you see flickers on your end. Hopefully you don't. So, what we're going to do today is rip out the system for the ship resources. And the reason is because right now it's incredibly complex and produces nothing but sharp walls. The gameplay of this game just does not support the kind of sudden stop that you get when you plan things out with specific end limits and specific times and stuff like that. So we're going to remove all of these elements here and replace them with a much simpler system that will allow us to make it easier for us to build ships and also more interesting for most players. The ability will, this new method will allow us to build quests automatically, and those missions are more important to me than making the ship construction more difficult and complicated. Mr. Idle sees no flickers, which is good. So what we're going to do is we're going to spend a lot of time ripping out every reference to existing resources and replacing them. We have a very complicated resources system, and I'll probably reuse something like it in some other day when I have to make a ship construction game that is supposed to be complicated. But for now, we're going to end up changing out all of these resource mix-ins. We just don't need very many of them anymore. We are going to, most of these mix-ins are not resource mix-ins. They're furniture, bed, and maneuvering jet and stuff. But these resource mix-ins have all got to be changed. So that's what we're going to do today. We're going to create this mix-in, drain, and mix-in exchanger. These are going to be different than they are right now, and same with the stockpile and the trickle required. Trickle required, yeah. Basically, we're going to be creating a lot of new mix-ins. So let's go ahead and open up one of these, and we'll create our new mix-in based on the old mix-in. And it'll be the same kind of system. So close others, and let's duplicate this. Mix-in resource. There we go. So let's see. It's not in its own specific namespace, but I think it would be good if we did start to use a namespace for this sort of thing. So let's go ahead and call this namespace engineering. And we're going to descend from ship component mix-in. So what our job now is, we're no longer going to say that a specific thing provides a specific amount of a specific resource. Instead, we're going to break it into something a lot more basic. So we're going to have the type of resource. And we're going to have a category of supply, and that's an enum that currently only has 3 things in it. And that's going to be main, auxiliary, I think that's how you spell it. Let's just double check that's how you spell it. Auxiliary, yeah. It's always just written as aux everywhere you go, so it's hard for me to remember it. And lastly, there's going to be luxury or something similar to that. Let's think for a second. Do we want it to be luxury? It's the alternate stuff, like if you have a greenhouse aboard, it doesn't just provide you with food, it provides you with really great food. So the difference is that auxiliary and luxury give you the same statistical result, but luxury is used differently in missions. So that should be fine. Public resource supply type. Supply type. And that should be enough, except we do want to have a required resource if we need it. The question is, do we put that here in the mix-in resource, or do we have that as a separate mix-in? And I think it's easier to put it in here. So we'll go ahead and say public bool requires input. Let's not even bother with that. I would just say string required. Well, there are situations where we'd have more than one. Well, for now, we'll just go ahead and do it like this. Later, we can change it. Make it empty here. And that way, what we have is the ability to automatically supply a given resource at a specific amount, and we can just calculate this stuff out as it needs to be calculated. Now, if we look at the mix-in resource, there is a lot of complex stuff going on here. And one of the big advantages of this approach is that we can just say, and not bother with that anymore. But there are a few details that we're going to need to keep if we want to be able to interact with the ship. Update resources on board the ship has to be completely changed, and we're going to have a fun time with that, I guess. That's going to be like a lot of the crap we're going to be trying to get rid of. We're going to go through a lot of this stuff, and it's going to be like, oh, look at these 10 billion errors, and we're just going to have to live with that. So what we've got here is ship resource abstraction resources. The resource abstraction system is a mathematical abstraction that allows us to run 10,000 ships without needing to actually load the ships, because we can just say, you know, the last resource, and you know, we last noticed this resource on June 1st, and now it's June 9th, and we have this decay rate, so we can just calculate out how much of the resource we've lost. But that's not going to be necessary anymore. From now on, our ship resource abstraction is just, does this resource exist? How much aux and how much luxury? So that's what we're going to be doing next. Here's the ship resource abstraction right here, and we're going to go ahead and fix that up. Public bool exists equals true, or public bool main equals true. Protect our public int aux equals 0. Public int lux equals 0. And we'll delete the rest of that complicated stuff. We don't need it. Similarly, the ship mission abstraction is going to have to go. It's just wrong. We'll deal with that later too. Let's go ahead and just... Should I just flat out delete it now? Let's only delete one thing at a time. Otherwise, it will be a problem. I'm about to sneeze and I'm trying not to. Sorry. Hoo-ah. So when we actually use this ship resource abstraction, here it is. Custom update, float hours past. So this hours past is no longer going to be terribly interesting to us. It's going to be much more simplified than it used to be. But what we're going to want to do is get all of these resource abstractions set up. And that means doing things completely differently. But it also means sneezing and blowing my nose. Hold on. Hey, Cartonio. I don't think there's really an everyone to say hi to, but it's good to see you. So, I was thinking about switching away from Saturdays, because it turns out that Saturdays are much more important now. It's the day when every protest is scheduled, so I might switch to Sundays. I'll have to think about that, but let me know whether or not you folks are have a strong opinion on the matter. Either way, we're going to need to get this resource system up and running, and I'm trying to figure out the best way to do it. I guess the basic way to do it is to just get rid of all of these references and start over. Leave the mission resources there for the moment because we only want to delete one thing at a time. Now there's probably going to be a metric crap ton of error messages. Yep, because that's kind of what we expect. The ship resource abstraction is core to a lot of the way that we've got our resources set up, and that's no longer going to be the case. So here we have this float find resource, and that's not going to be important to us anymore. We're just going to delete that. We're going to re-implement it later, but for now we're just going to flat out delete it. And that will create more errors. Mr. Idle says he doesn't care whether it's on Saturday or Sunday. That would be good. Here we have an update resources on the class Mixin Resource Drain. So the truth is that Mixin Resource Drain is going to go away. We're not going to use it at all. So there's no reason to even have this function anymore. And we'll just get rid of it. Well, we can't get rid of it because it's... Well, no, that's fine. We can get rid of it. We may re-implement the resource drain, but there's a couple of different kinds of resource drain because we want the resource drain system to integrate with the mission system rather than with the resource system. It's more important to know that a given resource is important during a mission and less important to know whether or not it's available at any given moment of any given second of any given day. Here we are. So this is the update resources within the Mixin Resource Exchanger, and we don't need it, so we're going to just comment it out. We're going to end up deleting these entire files. These classes are just going to completely go away, and that's fine. We don't need them anymore. But before I delete them, I would like to turn them into stubs. So this is update resources on the Mixin resource stockpiles, and we're just going to go ahead and comment that out as well. We want to comment out the actual full function here. Now these should already be okay to be commented out because only the ship should be calling them, and we're obviously going to be fixing that up. Here we've got a Mixin resource trickle required with a custom update. We're just going to go ahead and comment that out. So here we've got a couple of differences in the ship resource UI. Now the ship resource UI is going to have to get a complete overhaul because it is bad. It's not only slow, it no longer actually works for what we need it to work for. So we're going to want to completely revamp this ship resource UI. The question is, do we want to completely revamp it by just deleting it, or do we want to make an attempt to refactor it? Well, I think what we're going to want to do is refactor it because it's already pretty well integrated into the pipeline, and it would be kind of a shame. Well, reprogramming it from scratch wouldn't be too difficult, so maybe that is something we should do. Yeah, let's go ahead and delete the ship resource UI. To be honest, we don't want to delete the class. Yeah, sorry, I'm going back and forth on exactly how this is going to work. So we're going to go ahead and fix this up so that it is correct. This is all fine. This human number stuff doesn't work anymore. So we're just going to go ahead and refactor it. It's not even an amount per hour anymore. We'll just get rid of that. We'll bring it back later. So here in the refresh, what we do right now is we try and figure out whether or not we have the resources and what sort of values we've got. This is now going to be a much more straightforward text system. So if resource.main equals false, then we'll go ahead and create a text for it. So string human text. Human text equals needs, or what do you call it? Needed. Main needed. Or supply needed. There we are. Otherwise, we'll just go ahead and make human text equals okay. So we're actually going to want to be a little bit more delicate than that. So here in the if we don't have a main resource, we're going to say if resource.aux is less than or equal to 0, then human text equals supply needed, else human text equals aux only plus resource.aux. Down here, if we have a supply, we're going to want to say that it's okay. If resource.aux is less than or equal to 0, human text equals okay. Or as I say in the video, enough. Okay is probably better though. Otherwise, we want to say human text equals aux plus and then resource.aux. But there is another variant here. If resource.lux is greater than 0, then human text plus equals space lux plus and then resource.lux. And then at the end, all we need to do is say that our resource text dot text equals our human text. So I'm going to go ahead and if resource text equals null, return. Put in some safeties. And there we go. We got the highlight resources still in effect. Yeah, I guess we refactored in the end. It's fine. Oh, come on. I know there's more errors than that. There's no way that it was that fast. Well, I do know that we've got a couple of details left that we have to fix. One of them is the actual display on the engineering panel. We changed some names, and obviously it's going to need some work. So I think that is in... is that in the ship overview panel? Yeah, I think it is. Yeah, it is. So normally what happens is the ship overview panel is really archaic and old, but it takes these resources in and it sticks them right here in the content section. For now, we'll leave that as it is. We'll go down to the prefabs and take a look for it. I think it's probably in UI. It's a resource UI. There it is. We'll just drop it in. That's what it looks like. And we're going to just change it out so that it's more in line with what we need. Pardon all of the weird things in front of it at random. That's just because of how I'm editing it, it looks really strange. Here you can see resource text doesn't currently have a value. So we're just going to go ahead and drop this in. That's going to be our resource text. Don't need this anymore. Yeah, that's fine. And what we're going to do is shrink this resource UI to be the correct height, which is 45. There we go. And then we will apply it. Boom, like so. Delete the ship overview like this. And let's just go ahead and see what happens. The answer is nothing should pop up. The basic core issue is that we do not yet have anything with the new resource system in mind. So nothing should ever pop up. There shouldn't be any resources in the game right now. The things that used to be resources are now irrelevant and shouldn't work. Yep. So we do have these blocked in pop-ups for the various kinds of resources. Haven't decided whether I'm going to keep those or not. I'm kind of thinking maybe I won't. But I do kind of I kind of like the idea that you can see the interior volumes, because the alternative would of course be to have some kind of glowing halo around the parts that were, that mattered. Well, I can decide later. It's not important right now. What is important right now is that we go through and we fix up all of our various prefabs so that they use the new power system, the new resource system. So if we take a look, here in antenna, we've got a mix and mission component. So this one doesn't have a drain attached or anything. Fuel cell, here's one. The fuel cell has... Oh, it's part of the... I bet it's interior, isn't it? Yeah. So it has a mix and resource stockpile here. And what we're going to do is replace that with our new system. And that means that we're not going to use this mix and resource stockpile. We're just going to use the mix and resource. And that's going to be energy, I called it, rather than electricity. That's fine. Let's go ahead and make the default energy rather than electricity. Here we are. So this is a fuel cell, and it is not intended to be a primary source of power. So what we're going to do is we're going to say that it is an auxiliary source of power. Now, in theory, this actually converts water into power. I think we're going to just go ahead and say that that's not important for us right now. We could add in water as a required resource, though, so let's go ahead and do that. Yeah, that should work. Get rid of this guy. Boom. And now we can apply. There we are. So we do not yet have the ship seeking out for... hey, Pink Hair 3D. So we don't yet have the ship looking for these new kinds of resources. That's something we're going to want to do nowish. So here in the ship, we've got a lot of functions. It's getting pretty complex. But what we want to do is figure out where we update resources and fetch the new class of resource instead of the old class of resource. As it turns out, we went through and commented out a huge chunk of the resource system. Here it is. So this is in Highlight UI. This is in Highlight Resource, where it looks through and tries to highlight specific things for the resources. We're going to want to fix this. So to do, make it highlight our new resources. We're going to go ahead and leave that for later, though. Well, we could probably just fix it up here. So we have a list of all of our mixins, and we can say if mixin is a mixin resource, and mixin as mixin resource.resource equals resource. It's in the new engineering subset, so we'll go ahead and add that in using engineering. A mixin resource. There you are. Then we visualize it. So we only visualize it if it is the new kind of resource system. But that's not going to fetch a list of the new resources. We need to fetch that list. And it may be that it doesn't actually happen on the ship. It may be that there is another class. So here's the ship script. Here's the ship pilot. Here's the ship manager. So something on the ship is responsible for gathering those values. Is it ship component list? No, I don't think so. So apparently the component list is responsible for it. That seems like it's a little bit stupid. I think the issue was that it was getting pretty heavyweight and I wanted to remove it from the ship, but we've just reduced that weight quite considerably. So what we can do is either keep foisting it off on the component list, or we can manually calculate it here. Now the advantage of component list is I don't have to load it. When I load up the ship, I can just not load up the component list, and because the resources are stored on the ship, I can just know what they are. Well, for now, let's go ahead and keep using the component list as it has been used, which is to recalculate the resources here. So here we can see that the ship.resources.clear, but where do I fill the ship.resources? I think I might have just deleted it, and I should have left it in here because I'm not 100% sure where the... Oh, here it is. Well, that relies on something stupid. So what we want to do is we want to recalculate the resource inclusion whenever any object gets added to or moved from our list. And that means that it is a good idea for it to be in our ship component list. And you can see that on transform children changed here, it recalculates. I think this is why I put it here, actually, because the on transform children change only triggers one layer deep. So if it was on the ship, it wouldn't work because there's ships, and then within the ship is a part list, and then within the part transform is all the parts. So if I put this on transform children on changed on the ship, it wouldn't detect any of the parts getting added. But if it's on the ship component list, then I can do that. Let's go ahead and make a note of that. This handles the parts that are added to or removed from the ship. It will automatically trigger a recalculation whenever any part is added, unless that part is within another part. In those cases, manual recalculation will need to be triggered. There we are. And so here we clear out the ship resources. I'm just going to go ahead and recalculate them right here as well. Previously, we didn't recalculate them because there was an extremely complicated hierarchy as to exactly when what resources popped into existence for who. That's all gone now. We don't need that kind of complexity screwing up our gameplay, so we're just going to go ahead and gather the resources in an old-fashioned way. Ship resource... oh, no, sorry, mix-in resource. We're going to want to use the engineering. To be honest, the ship component list should be in engineering, so let's go ahead and do that. Namespace engineering. Mix-in resource, array, resources, equals get components in children, mix-in resource, true. No, there we are, true. And that will just fetch a list of every single mix-in resource within the ship. Well, within the parts section of our ship. If we've got other modules that aren't actually attached to our ship, but are like in cargo or being dragged or whatever, it won't find those. And that's why it's in its own little sub-directory, its own little part of the tree. So from here, what we're going to do is we're going to go ahead and build the stuff that we need for our resources. So for each mix-in resource, resource in resources, M resource and M resources, because they're mix-ins. So within that, we're going to want to fetch from the ship our actual resource abstraction. So resource abstraction resource equals ship dot resource, find resource abstraction, and then we pass it the name of our resource, and we add it if it's missing. So mResource dot resource. And we're also going to want to add in any required resources. There. If mResource dot required resources does not equal nothing, then do this part. So that will create, so what this does is if we require a resource to run this particular converter, we're going to create a registry for that resource. We're actually going to reach out to the ship and ask the ship, hey, about this resource. And the ship will say, well, here's everything I know about that resource. And if it doesn't exist yet, the ship will create it and say, everything I know about that resource is that I don't have any. And that's already implemented. I don't have to worry about that. But basically, this is actually all we need to do in order to trigger the creation of a slot for a resource, even when we don't have a resource. So if we require water in order to create electricity, then this will say, please tell me about water. And the ship will say, I don't have any. And that will automatically and permanently register water as a resource on the ship. And when we display it, it will automatically display as you need water. Here, on the other hand, this one's going to be creating the resource if it doesn't exist, but we're also going to want to set it up properly. So for our sake, what we need to understand is whether or not this is a main or what. So switch resource mResource dot resource type, which is supply type. There it is. We do default debug.log error, dunno the supply type plus, and then the supply type. And that's just future proofing. Case supply type dot main. So here is the most complicated one. So we'll do it last. Case resource supply type .aux. So if it's an auxiliary resource, then we add it in as an auxiliary resource. Resource.aux++. Pretty simple. Case resource supply abstraction.lux. Lux, here it is. Resource.aux++ and resource.lux++. Break. Now, if it's main, there are two ways this could go. If we don't yet have a main resource of that type, then now we do. If resource.main equals false, then resource.main equals true. Else, we want to add an arbitrary amount to our auxiliary resource. I think 4 is a good number. So what that means is that if we have 2 reactors on board the ship, we're going to end up with a lot of auxiliary supply. So if our main reactor goes down, we're still going to have a full reactor left over. To be honest, I think 2 is probably better, because now that I'm thinking about it, the recalculation will automatically register that as a new main if the primary main goes down, so we're not going to worry about it. And this is going to be a plus equals, not just an equals. One thing we want to check is we're going to want to verify that our resource abstractions start with that as false. False. I knew that was a mistake I had made. That would have screwed us up pretty bad. Everyone would have had free major resources. Okay, so that now should automatically add in all of our required resources and all of the resources that we have. Let's go ahead and try it out with our friend, the only registered resource, the fuel cell. F is for fuel cell. That's good enough for me. There we are. Fuel cell. Open up engineering, and you can see that it says aux only +2. Supply needed. See? Isn't that so much easier than 100 gigawatts per hour and then draining 1 liter per day and trying to keep track of that stuff? Now we know that we're on auxiliary only and we need some water. Boom. Super easy. Now, if you're wondering why I'm simplifying it like this, and there's already been some pushback on this, even though I have like 4 people that actually pay attention, the reason that I'm simplifying is not because I want to make the game simpler. It's because I want to make the game more complicated, but I don't want that complexity to be at the shipbuilding stage. I want it to be during the gameplay. So I want to make the actual shipbuilding part really, really easy for everyone to get a handle on. I want people to be like, yeah, I built this cool ship, and then they get to see how it actually works in missions throughout the game. And that means that hard limits and specific hours of operation aren't going to be of any use to us. We need to have a more general understanding so that we can lock together a whole bunch of slightly randomized mission templates based on what your available resources are. So let's go through and continue to refactor all of our resources. So that was our fuel cell, our bathroom, cockpit, nuclear reactor. Here's one. So here is a nuclear reactor. Currently it has a stockpile and a process. The stockpile is, what we could do here is we could keep track of the nuclear material separately from the actual nuclear system if we would like, but we're not going to bother. In this case, it's just going to be a waste if we try and do that. So we're going to remove the stockpile. Goodbye, stockpile. And here in the process, we're going to add in our mix-in resource. It's going to be type energy, and it's going to be a supply type main. And there's not going to be any required resource. So if you put in one of these big honking reactors, then guess what? You have a big honking reactor. You don't need to worry about a resource chain for it. It does require uranium, but we're going to assume that the uranium is already local to the reactor, and you don't have to worry about keeping a separate supply. We'll deal with all that stuff later if we want to make it more complicated. It's not too difficult. Yep, that looks good. We'll save that reactor. Now let's go ahead and test it out in the game. So if we were to load up a ship with a nuclear reactor and a couple of batteries, we should see a more mature energy rating. So there's no nuclear reactor on this ship. Okay, let's try again, loading up a ship that has a nuclear reactor. That one has a nuclear reactor. So here you can see that it has energy and electricity as separate objects. So I accidentally left the fuel cells as energy, or electricity rather. Let's go ahead and fix that because they are energy. I think I just forgot to save it. I remember making that change, but that's fine. Let's go ahead and fix it up. Boom, there it is. It should be like 4 aux and main, of course. Yeah, energy aux plus 4. So we have plenty of auxiliary energy around now. So we have the main reactor and we have the auxiliary stuff, and it all works great. Now, the funny thing is that it's not highlighting correctly. The batteries highlight correctly, but the reactor does not. Huh. Well, I'll work on that later. Well, might as well try and figure out what's up with it now. The problem is that this process object isn't turning on properly when we go into engineering view. Well, what's the difference between this and the fuel cell? Not the fuel tank, fuel cell. The fuel cell has a stockpile. It's off. It's on the highlight layer. It's on the mix and resource as usual. Engineering display 3D. Engineering display 3D. Well, this still has a mix and exchanger attached to it. That might be the problem. It doesn't have a required resource, but I can't imagine that that would cause that to not show up. That seems like a weird problem to have. Okay, well, let's just put in the one thing so there's no delays when we're mousing around, because I have to optimize the hell out of that. Where's our reactor? There it is. So there's our reactor, and when we open up engineering, we can see that it's okay and it exists. So it must have just been the fact that it had one of those archaic resources still attached to it. That's fine. We'll be changing that out later on because it's really ugly right now, but you can see the basic idea is starting to come through. Heavy ion thruster. Hurrah! So the heavy ion thruster is something which requires a resource but doesn't provide one. So what we're going to do is we're going to go ahead and put in an optional on the resource abstraction as well. So here we're going to say on the output resource. So here we're going to say if m resource does not equal nothing, then do this stuff. So that means we can use the same class whether or not we're just eating a resource, or whether we're creating a resource, or whether we're doing both. So our engines will require that resource, but they won't produce anything. Here's the resource drain in question. More resource drain. So we're going to remove this one. Here's the process here. So previously I was just playing fast and loose with what kind of resource it was using, and I was using just hydrogen, because hydrogen is something you can get out of water and there's an exchange and stuff. Hydrogen's actually not a very good particle engine resource. It's just better than not having a resource at all. What we're going to do instead is we're going to use a more opaque version. We're not going to call it hydrogen. We're going to call it something else. What is a name for passive material that is used, you fire it out of an ion engine? It's not monopropellant, because that's like something else. I think. Let me look it up here. Monopropellant. Yeah, that's just a chemical propulsion fuel. I'm not looking for the chemical propulsion fuel. I'm looking for a non-chemical. I'm looking for atomic propulsion fuel. And I think xenon is the preferred one. I don't want to be that specific, though. I just want to be super generic about it. Well, if I look up xenon and ion drive, I bet it'll tell me what that's generally called. They just call it propellant. Well, we'll call it propellant too then. Why not? Why not? Well, exhaust is what it turns into, pink hair, but what I need is the video. I need a description of what to call it. Yeah, the xenon is obviously the best fuel, but the point is that you can use anything, and this is a sufficiently advanced engine that you could use hydrogen or xenon or anything else you wanted to fire out the back, and it wouldn't be as efficient, but it would, generally work. I think we're going to call it propellant. There we are. But we actually need to have like an energy drain as well. So it's not just the propellant, it's also the energy drain. like so. We'll go ahead and save that, and let's take a look at it in our game world. Yep, pretty much. The whole idea with this is the hardcore engineering is not the point. I could make a game where that was the point, but I like Kerbal well enough as it is. So here you can see that it says propellant supply needed, energy supply needed, and empty supply needed. For some reason, propellant and energy don't trigger that, but this does. So here we say ship component.visualize, right? And this contains a lot of details as to how a ship component gets visualized. We're going to go ahead and actually mention what the heck is getting visualized. So what happens here in the ship component.visualize is name plus visualize. There we are. We look into it and we say turn on all the mixins. And that will turn on every single mixin, including our new ones. And they should just, that block of red should just appear. Now that we have name visualized, that should be a little bit better. We should be able to tell a little bit better. But one of the things we need to do is in ship highlight resource, we need to make it clear what resource is getting highlighted. Debug.log highlighting resource. And we're also going to want to write down the resources that we are creating when we look for resources. So debug.log adding output resource and then the name of the resource. And then here we'll say adding input resource and then the name of the resource. Oh, I deleted it. There. Clear. That wasn't clear. Clear, and then pull it up. Drop in an engine and open up our engineering. And here you can see that it says showing resource UI for ship template, showing resource UI for ship template. That's all fine. Heavy ion thruster visualized. That's fine. So when we do this, highlighting resource energy, it actually turns off. Oh, you know why? Because those are negative and we're only looking for positive. So we're going to want to have them both activate. And we can do that over here in the ship. When we highlight it, here, you see this? Mixin resource equals resource. We're going to want to have this doubled up. So it's and mixin resource equals resource, or mixin resource required. There we are. That should do. But I also have an error in our mixin resource system for here. There we are. So, yeah. So here's the problem right here. Here's the bug. This is what was adding the empty entry. You may have guessed that. There we are. Now that it's inside the brackets, we shouldn't have that problem anymore. Pull up the heavy ion thruster, and now it should require propellant and electricity. Yep, propellant and electricity. And they're active. Good. So what we can do is we can add in a source of electricity, like, say, this, just some auxiliary batteries. And we can attach them to our engines like this. Boom. Pull it up. And you can see that it still says energy supply needed. Adding resource water. Now have 3. Find resource abstraction. Are these water? Oh, that's for the... Sorry, that's intake. Oh, no, wait. Yeah. Yeah, that should be intake. But you can see that water is not here on the ship template. It looks like this might not be regenerating. Hello? That was slow. Alright, so we have a problem where this isn't properly regenerating, and we'll have to keep our eye on that and try and fix it as soon as I figure out what the issue is. But for now, let's go through and continue putting these objects into the new regime of resources. So here's a fuel tank. And the rocket fuel is not just, propellant. Rocket fuel is rocket fuel. So we're going to go ahead and put that in. Here's our stockpile. We add in a mix-in resource of rocket fuel. And that's a main supply. That is fine. It doesn't need anything. It just sits there on its own. Boom. Perfect. Yeah, that's fine. Apply. And what we're going to need to do is move on down. Nuclear reactor, ion thruster, hydrogen tank. So this is a hydrogen tank, but to be honest, it should be a propellant tank, not hydrogen specifically. So let's go ahead and change some names. Just delete this for now, and here we'll just call this a propellant tank. But that's not going to, that's going to break all of our ships. Won't that be fun? So we're going to have to deal with that. That's fine, though. We don't have a resource drain here. We used to have a resource drain because it was cryo stored, and I think it probably still is. But for now, we don't really need to worry about it. We'll go in and we'll call this propellant. To be honest, this doesn't look like a very big propellant tank, but that's fine. We're going to go ahead and require energy because it's still going to be cryo-frozen. There we are. Seems fine. Boom. Here's a light. We're going to go ahead and have this resource trickle required, remove it, and add in mix-in resource energy with nothing up here. Apply it. Maneuvering jet. So the maneuvering jet uses water in the current version, and I think that's probably going to stay, at least for the moment. So let's remove this. Do we have a process? Here it is. So mix-in resource water. Oh, it also requires energy, huh? All right. Propellant tank, radio dish. I don't think the radio dish actually has any active resource requirements. Oh, it does. It has a resource drain. So we'll go ahead and just switch that up. Rocket thruster. This is fine, but currently it doesn't have the right drain attached. So here we're just going to go ahead and insert a mix-in resource with a fuel drain. That should do. Don't need to have any output. And we're going to change this from cylinder to engineering. or some other term that makes more sense. And we're going to remove this old-fashioned thing that doesn't work anymore. And apply. Side box. These are cargo boxes. So previously, I just had a generic object called supplies. I think I'm going to keep with that. Do I want to switch the word supply for the word cargo? Do I want to say instead of supplies, it's cargo? Because cargo is more generic, and it might make more sense. Supplies are pretty specific. Yeah, let's switch it out for cargo. We can always change it again later. Here's a supply pouch, which will just do the same thing. Utility arm. I think this requires energy. Yeah. Water tank. Obviously, we want to have water in our water tank. There we are. So at this stage, we've converted all of our T1 Corvette info. The problem is that we have a lot of T1 Corvettes that have hydrogen tanks. And since there's nothing called hydrogen tank anymore, they are going to barf errors. If we look here, we can see it saying could not track down hydrogen tank. And you can see that there are no hydrogen tanks on this vehicle. What a shame. If we go over here into engineering, pull it up, we can see that we have a supply needed of propellant, because that was what our hydrogen tanks used to be. But everything else looks good. So what we're going to do is just go ahead and stick on some propellant. Of course, now this vehicle is radically over-engineered. If we look at the engineering section, you can see that we have aux plus 14 for cargo, which is a ridiculous amount of cargo. That makes this into a cargo carrier. Now, part of that is the fact that the cargo boxes were quite small, and it might make sense for us to increase their size. And part of that might be that this might not be the best approach for worrying about cargo liners. And we'll think about it later. But either way, this needs to have some propellant tanks added to it. So let's go ahead and do just that. Propellant tank. There we are. And if we take a look, we now have propellant. It says supply needed because it doesn't refresh properly. But it's there. It doesn't need a supply anymore. It's working fine. Go away. This needs to be optimized a lot. It's terrible. So what we're going to do is save the ship. Slow, but has plenty of supplies. And now what we're going to do is load up a different ship like this, Agrippa. The funny thing is, it's actually a lot faster in the release version. The debug version has massive slowdowns. If you remember, in the release version, that engineering section has no delays at all. It just works. And that's because the way that the debugger works, there's a whole bunch of added overhead when you enable and disable objects. And that includes the loading section. If we look in here, you can see that we have even more cargo. Who needs this much cargo? It says that we've got aux plus 2 propellant. This must be from the last ship. So it's one phase behind. That's the problem right now. Because this certainly doesn't have any propellant tanks. It's physically impossible for it to have any propellant tanks. But they go in the same place they went last time. Right there. Which is why I built them like that. Save that. And you can see that it's fairly straightforward to make this work. And if we were going to be a little bit more careful, we could load up a ship like the one we just fixed, the Agrippa, and we can see what the supply levels actually are, because they're not supplies plus 14. We also have 2 other sets of objects that need to be fixed, which we'll get to in a minute. Here we are. So it's still plenty of cargo, Ox plus 10, but it's no longer ridiculous. We got enough propellant and water and energy in case almost anything happens. These things are radically over-engineered because they were engineered back in the era when I was trying very hard to make this more like Kerbal, and that was a mistake. I don't want it to be more like Kerbal. I want the opposite of that. Thank you. Well, we have to go and do some other objects in our other systems. So here we are. Cargo core, drop that in, fix it up so that it's properly set up. Yeah. Now this has a secondary set for its interior, but that's not something we have to worry about at the moment. Fuel tank. Power. Cargo core again. Fuel tank again. Power core again. Funny thing is, I do not know if this has a water tank, even though these power cores require the water tanks. I have a feeling they don't. Which is obviously something that I will need to fix before we go into full release of any kind. Here we are. We need to have a water input, so we'll just go ahead and do that. And Outrigger scanner, I believe, requires power. Yeah. Rocket engine obviously requires rocket fuel. Tapered fuel tank provides fuel. And that should be all that we needed for that set. Now we'll take a look at the early era ships and fix them up. We got a battery. Battery provides auxiliary power. Although it's a huge battery. To be honest, I'm going to make this provide main power. Box of supplies obviously provides a little bit of cargo. Bumper, fuel cell. This is going to be providing the auxiliary. Oh, makes sense. What does this look like? That's fine. I got a light. This has a trickle requirement, which we're going to switch out for our drain. Maneuvering jet. Requires water. These T0 maneuvering jets don't require power, they just require water. To be honest, they should require monoprop, not water. But I didn't want to add another kind of fuel. Rocket engine obviously eats up fuel. I'm going to go ahead and change our defaults. Ship resource. There it is. That'll be a little bit easier to work with. Sensor dish, I think this has a drain attached to it. Yeah. For some reason, the sensor dish requires fuel. I think that is just me mistyping something, because obviously the sensor dish does not burn gasoline. That doesn't make a whole lot of sense. Small cockpit. Here's a rocket fuel tank. Let's set it up properly here with a supply of fuel. Here's a water tank with a supply of water. Now, one of the weaknesses of what we've done here is we haven't set up any difference in the scale of these objects. So at the moment, I could add in, a small ship rocket fuel tank, and it would be able to power a larger engine. Now, the simple truth is that the scale of the ships is already in the game. It's just named the wrong thing. So we're going to work with that. If we go down into our scripts, we have a what are they called? We could just go up here and check. Here they are, the manifests. See these manifests? They actually have a ship scale. Maybe they don't. I guess they don't have a ship scale built into them. Well, that's fine, because you know what we're going to do? We're going to build a ship scale into them, and that will make it express as to exactly what sort of scale each of these objects are. So we're going to go down here to manufacturer, catalog, and then here we're going to have public int ship size. Like that. So every object that gets created has a link back to its catalog, and we can reflect that by going over into these ship mixins or ship components. The ship component is the place it's supposed to be here. And what we want to do is be able to get the size category. Now, the size category for these can be fetched by going out and fetching the catalog and storing that value locally. There is no link to the catalog itself. There is just the metadata about where to find the catalog. That's not the best way to do it. I mean, I can see why that is the case, but it's not great. So here you can see find manufacturer catalog. We're going to go ahead and add that into the ship components. Protected catalog manifest. Catalog. Yeah. Public catalog manifest. Catalog. Oh, this is going to be catalog manifest, I guess. We'll use the full word because we've already got something named catalog. And then here we will say get if catalog manifest does not equal null, return catalog manifest. Otherwise, we want to make sure that we own it. So catalog manifest equals catalog manifest dot find, and then we pass it our manufacturer and our catalog. Well, each of these objects has a ship type attached to it, which is odd because that's not where it should be. It should be on the catalog, not on the individual object. So we're just going to go ahead and get rid of that. Let's see now. So if we use catalog manifest.find, we look for it in our list of loaded manifests. If the loaded manifests doesn't contain that, then it's going to return a null. So we're going to want to barf if that happens. Name plus couldn't find manifest plus manufacturer plus catalog return. Oh, let me just return there. There we are. So all of the catalog manifests get loaded up without loading up the individual parts. So it's relatively lightweight to load up a list of all of the catalogs, and that happens at load time. The specific catalogs that get loaded up over the course of play will take a little bit more time because that's loading up actual parts and meshes and textures. But the actual catalog manifest is a really, really tiny class. It doesn't have any significant load. So it will exist unless you've uninstalled that catalog, in which case this will go, Public int size, or ship size, ship scale, what did I call it? Ship size, we'll call it ship scale. If catalog manifest does not equal null, return catalog manifest dot ship scale. Else, return -1. So the point of this is that we're going to be able to get the ship scale of any given ship component just by asking the component for it. And that will allow us to calculate out the resources with a size deviation. Now the ship itself is going to have a ship scale in order for that to make any sense. So yeah, we'll add that in. Here you can see ship type equals small ship. This needs to be a ship scale. Now what we want to do is load, max this to the largest object added to our ship. And of course we do that over here in the ship component list. So when we recalculate, we're going to want to calculate the largest size that that is around. So find the largest object on the ship. That's our scale. Int scale equals 0. For each component, ship component, comp in components, if com dot ship scale is greater than scale equals com dot ship scale. There we go. Down here in our components, we're going to want to check and see if we're from a smaller scale ship, then rules change. So if m resource dot do we keep track of the components? Okay, so if we look over on our mixin resource, we've got a ship component mixin, go to declaration, ship component. So this is protected. That's why we can't get it. So we're going to go ahead and make that public. But we might as well also get a scale. So public int ship scale. And we're going to go ahead and get return parent dot ship scale. So then what we do is we go back into our ship component list and we look for that. So well, I guess the easiest way to do it is to actually take it outside a little bit. So resource supply type equals m resource dot supply type. If is that not? Oh, there it is. If what we're doing now is we're going to detect whether or not it's small, and if it's small, we're going to reduce the resource supply type. So that should be fun. And that means we're going to want to add a new resource supply type. Give me a second. Mixin resource, mixin supply types, main, auxiliary, luxury, none. There we are. And what we're going to do is, there we are. If m resource dot ship scale is equal to ship scale or ship dot ship scale -1, then we reduce the type. So if type equals main, then type equals aux, else there's no double equal there, type equals none. Else if m resource dot ship scale is less than ship dot ship scale, type equals none. Case none. Break. And that should automatically reduce any main supply to an auxiliary supply if it's smaller than the scale of our ship. And that's great. That's exactly what we need. And that means that you can combine smaller and larger scale objects. You just have to be careful about how you do it. It also means that you have a lot more options. If you don't want to add in the auxiliaries from the current size ship, you can always add in the mains from a smaller ship and they will count as auxiliaries. So instead of those large batteries, you could add in small fuel cells or something similar. Either way, that should be all we needed, and it should still all work. Here we are. If ship type does not equal null, ship type text equals ship.ship type. Well, we're going to want to humanize that. So public text, public string, human ship type. Int scale. And I actually have a list of these, but for now we'll just go ahead and put in a switch scale. We're going to want to make this region specific, but for now we'll just hard code it. Case 2, return Corvette. I think it's a Corvette. Case 3, return frigate. Take a quick look into our models, ship models, corvettes, and destroyers. So it's then the next level up is a destroyer. Then it's a cruiser. And then it is a mothership, maybe. Default, return unknown class size, and then the scale. So down here, we say human ship type ship.shipScale. So we do have an issue now where we haven't actually set up the scale of these manifests. So that's what we're going to do now. We defaulted to 2, which is correct, except for the small ships. The small ship is a 1. Perfect. Now we have one more problem, and that is that refreshing that UI didn't seem to be working. The ship resources UI wasn't correctly regenerating. And that might be something that never worked. I haven't tried it in ages. But we need to make it so that this ship component system actually functions. So close others. This needs to regenerate whenever our ship tells it that something has changed. And there are 2 things that keep track of that. There's the ship component list, and there is the ship itself. So when we change a component, we recalculate, and up here in the recalculation, we clear the resources on the ship, and then we do all of this dancing here. But at some point on the ship, we have to know that the ship resource UI, it doesn't even exist. Okay, so the ship has no concept of a ship resource UI. The ship resource UI initializes, and then it refreshes every update. The ship resource UI is an individual. Okay, so that's actually going to work fine. The problem is the ship resource UI isn't regenerating its... That didn't work fine last time. It was still broken. Ship engineering UI. That's what's causing some of these issues. Here we are. So the ship engineering UI initializes. It initializes the ship, huh? And what that does is resource display does not, if resource display does not equal null, then resource display dot initialize. The resource display is a ship resource. Oh, so there it is. A little bit too many levels of abstraction here, I think. Oh, that's because the engineering UI includes a lot of other stuff, and at least in theory, it's not just a resource list. Okay. Here it is. So this is the resource list that is controlling our list of objects. It's got this initialization here and this reinitialization, but the reinitialization probably never gets called. Let's take a look. Ship resource array. Ship resource array. No, it doesn't exist. So what we need to be able to do is to tell this thing to completely regenerate whenever it needs to. And probably the easiest way to do that is to have it sign up for a reinitialization event. So for that end, what we'll do is over here in our ship component list, we're going to have a static Unity event. Public Unity event on components changed. There we are, a static. Fun trick, if you use these static Unity events, you actually have to initialize them. Normally you don't have to, but you do if it's static, because it never shows up in the inspector and never gets initialized automatically. Over here, in this ship component list, we're going to want to hit this event at the end of this array, this function here. So on components change.invoke. And that should all work. I don't think we need this anymore. To do fix time passing. Because we're no longer time limited, so all that time passing stuff is nonsense. So here in initialize, we're going to want to sign up, or here in start, we're going to want to sign up for our events. Ship component list dot, is it engineering? I bet it's engineering. Using engineering. Ship component list dot on components changed dot add listener reinitialize. Boom. Let's try it out. Let's go ahead and load up a ship like the Slugger here. Grind, grind, grind. There we go. So there's the Slugger, and it's still got our new supply objects. Here is our list of things, and what we're going to want to do is start to edit stuff and see what changes. So it's hard for us to see what's going on because the engineering display is really badly designed. But you can still click on stuff, and you can see how by removing these, the cargo keeps dropping. See that? Pretty nice, right? So that's updating correctly. Let's go ahead and see what happens when we completely remove a category, like so. It automatically updates. And if we put it back in, it works. Great, so that works. That's all that we really needed to do. We do have a couple of small bugs, like this thing should automatically have the propellants and stuff, but we actually have to like bump it in order to have it work. The engineering overlay here has to be completely redone anyway, so I'm not too concerned. We have now completely switched over our ships. Our ships no longer use time-limited supply systems, and now they instead use mission-limited supply systems. And that should work better in the long run. I may have to tweak some of the specifics about how that works, but that is the basics. Let me know if you have any questions or opinions on the matter. I'm going to go ahead and take some screenshots and post them to Twitter, and then I'm going to finish off because my voice is scratchy. I also need to do a couple of things with the crew and stuff, but that'll wait. Let's go ahead and spawn in a crew just so we can have the full mix here. This needs to be completely revamped as well. Great. That's fine. Oh, it's not interior. Here. Probably got to get a better texture, but I've got to get a new model set anyway, so it doesn't really matter. There we go. We got our supplies. Yeah, so let's take some screenshots real quick here. Gosh, that needs to be optimized. Boom. Added a more robust mission-centric supply system to the game. Screenshot Saturday. Paste. Indie dev. Why not? Hashtags galore. Boom. Well, wasn't that fun? That went a lot easier than I was expecting. The old resource system was really, really complicated, and it just was actively working against the gameplay I was trying to build. So I know that there is a lot of pushback against the idea of simplifying things, because that goes against our nature as wannabe rocket engineers. But in this case, I think simplifying it will allow us a much more freeing experience, so that we can get on with running around the galaxy and having adventures. It won't be pointless. There's still a lot of depth here. Not only is there depth in terms of exactly what gets added and what's auxiliary and stuff, there's also depth in terms of how they're placed, because this placement matters a lot more than you might think. If you get damaged or something similar, the result is that it's always a radius effect, and that means that you're going to have to worry about what things are next to what things. Let's add in some fuel tanks if I can. There we are. And you can see that it's aux +2, even though those are primary fuel tanks. And the reason for that is because they're a size smaller. All right, good. I will see you next Wednesday and the Sunday after that. Mr. Idle says he has to watch previous videos to get caught up. I don't think you have to worry about it too much. This is live streaming dev work. Yeah, if you can keep up with me, then you're wasting a lot of time. As long as you find it relaxing to watch me develop stuff, then you are welcome to stop by, whether you're up to date or not. That's an interesting shadow. Cool. See you on Wednesday, everybody.